This lesson is our second day of volume, sections 11.4 through 11.8. We're going to start out with density, mass, and volume. So we did talk about population density, but now we're going to talk about density in terms of volume and mass. So density is a measure of how much mass is located within a specific volume of space. I typically think of density being mass over volume. That's the way I personally remember it, which is this formula right here. But there are other ones that you can use. If you remember this triangle, mass over density equals volume, right? M over D equals V. M over V equals D, mass over volume equals density. And mass equals density times volume. So if you remember this triangle, you could remember all three formulas. I tend to actually just remember this and have to convert it myself to the others. So for example 1, we are given the dimensions of a standard gold bar at Fort Knox. Gold has a density of 19.3 grams per cubic centimeter. We want to find the mass of a standard gold bar to the nearest gram. So in order to find the mass, given the density, we need the volume. So let's start with that. The problem is they're giving me the density in terms of grams per cubic centimeter, but the dimensions of the bar are in terms of inches. So if 1 inch equals 2.54 centimeters, we can multiply the 7 by 2.54 to get 17.78 centimeters. We can multiply the 3.625 by 2.54 to get 9.2075 centimeters. And we can multiply the 1.75 by 2.54 to get 4.445 centimeters. My volume of a prism, a rectangular prism, is length times width times height. So my volume will be these three values multiplied. So 17.78 times 9.2075 times 4.445, and I get a total volume of 727.688. So if density equals mass over volume, and we're solving for mass, mass equals density times volume. So mass, or weight, is the word we kind of use for it, but it doesn't really mean weight, but we're using it to mean weight, will equal 19.3 times our 727.688. So I get a mass, and they're asking to the nearest gram, so we're going to go nearest whole number, of 14,044 grams. So here's try 1. Find the mass of this concrete cylinder. The dimensions are already in centimeters for you, and we're given the density. Pause if you'd like. Answers are posted online. All right, example 2. A rectangular block of copper metal weighs 1,896 grams. The dimensions of the block are given. From this data, what is the density of copper? So we know that density is equal to mass divided by volume. So I know the mass, I know the weight is 1896 grams. So I have to divide it by the volume, which I don't know yet. But it is a rectangular prism, so we could find the volume by doing length times width times height. So if we do 8.4 times 5.5 times 4.6, I get a volume of 212.52, and that was centimeters cubed. So if I divide this, I get my density of 8.92, and now look at the units. Grams over cubic centimeters. So there's one here for you to try. Pause if you like. Answers are posted online. Example 3. A builder has constructed concrete pyramids to put on top of a fence post. They each have a mass of 110.4 grams. Concrete has a density of 2.3 grams per cubic centimeter. If the base of the pyramid is 4 by 4 centimeter square, what is the height of the pyramid? So they're giving me density and they're giving me mass. So I can use those two to determine the volume of the pyramid. So if density equals mass over volume, switch these, volume equals mass over density. So I'm going to divide my mass by my density to get a volume of 48. So now I know that I have a volume of 48 and it's a pyramid. So I can take the formula for volume of a pyramid. I could plug 48 in for V. I'm looking for the height and the area of the base. If it's a 4 by 4 centimeter square, 4 times 4 is 16 for the area of the base. So I'm going to multiply the 48 by 3 and divide by the 16. So my height is really 9 centimeters. So here's one for you to try. Pause. Answers are posted online. For example 4, the ancient pyramids were built with limestone blocks that weigh about 2 tons per cubic yard. So when they say weigh about 2 tons per cubic yard, they're talking about its mass. Oh, sorry, its density. I lied. Because the units, tons per cubic yard, the density. Find the length of the side of a square pyramid with a height of 80 yards if it was built with blocks weighing a total of 846,720 tons. So they're giving me the mass here. So this is mass, this is density. So again, volume would be mass divided by density. So we're going to take 846,720 and divide it by 2. So we get a volume of 43,360 cubic yards. I know the height of the pyramid is 80. So if I take my volume and equal it to the volume formula, right, BH over 3. I don't know B this time, but I know H is 80. So I'm going to multiply my 43,360 by 3 and divide it by 80 all at once. So B is equal to 1626. Something is seeming very wrong here. I'm wondering if I typed something in wrong. I did. I wrote it wrong. Hold on. Let's go back for a second. I knew that seemed wrong. This was 423,360. So 423,360. So we'll times that by 3 and divide it by 80. And I get the area of the base is 15,876. So that's the area of the square base, right? Our base, which has two sides that are the same, has an area of 15,876. So this is really equal to something squared. So if I take the square root of this, it'll give me one of my sides. And when I take the square root of that, I get 126. So that is how long each side is of that pyramid. Example 5. A grain silo is built from 2 right circular cones and a right circular cylinder. The height of the cylinder is 12 feet and the height of each cone is 7 feet. The radius of the cones and cylinder is 5 feet. If the grain has a density of 40 pounds per cubic foot, what is the total weight that is stored in the silo? So they're asking us to find the mass when we know the density is 40 pounds per cubic foot and we have the dimensions of all of our individual shapes, so we can find the volumes. I'm going to find the volumes and add them together because this is a composite figure. So my cylinder is pi times r squared times height. I'm going to leave everything, well, I'm going to leave this in terms of pi for right now. I don't know if it's going to come out to be something nice. It's not. I'm not going to bother. So this is 942.48. And now I have two different cones that have the same dimensions. So for two cones, that's 2 times pi r squared h over 3. So if I use my calculator to do all of this, I get 366.52 for my volume. So my total volume is 1,309. So add these up, and we get 1,309 cubic feet. So that's volume. And I know density. I'm looking for mass. If density equals mass over volume, mass equals density times volume. So we're going to do 40 times 1309. So we get an approximate mass of about 52,360 pounds. Example 6. A rectangular prism has a height of 2 inches, a width of x plus 4 inches, and a length of 3x inches. They're giving me the volume of the box is of 126 cubic inches. We want the dimensions. So we know for a rectangular prism, we could do length times width times height equals the volume. So multiply these three values that they gave me and set it equal to the volume that they gave me. So I'm going to do this in pieces. So we have 6x times x plus 4. So distribute 6x squared plus 24x. And now this is a quadratic. I want it equal to 0 to factor it, but I also don't want the 6 in front of the x squared. So I'm going to divide everything by 6 right now. So x squared plus 4x equals 21. So now let's move that over to get it equal to 0. And we're going to factor. We're looking for the two things that multiply to negative 21 and add to positive 4, like positive 7 and negative 3. So x could be negative 7 and x could be positive 3. Since I try to put x in here, I would get negative 21. The negative is out, so x really can only be 3. So let's find our dimensions. We have a height of 2. That was never going to change because that was that. A width was x plus 4, so 3 plus 4 is 7. Let's include our units. And our length was 3x, so 3 times 3 is 9 units. And if I wanted to check this out, 2 times 7 times 9 is in fact 126, which was the volume we were looking for. So for the very last one for you to try, same idea as our last example, and that is it for volume of our figures. That is the end of all of our lessons.